So as with everything, we have our foundation or our building blocks, and Lean is no exception. So Lean has its own language, and most of the Lean terms come from Japanese because that's where it started. And yes, there are the English equivalent, which some companies use because they don't want to use the Japanese terms, but let's dive into those terms or the lexicon of Lean. So we have a lot here. So we have Gemba. It's the real place. That's the physical place where the activity is occurring, such as the shop floor. So we have, and I don't speak Japanese, so some of these I'm going to skip saying because I don't know how to say them. When this next one is another one. Genshi Gembutsu. Butsu. Basically, go and observe the situation for yourself so you can understand it. So go see. If you've never seen it, how can you explain it and understand it? Most people learn by observing. So you can tell somebody everything, but if they don't actually see it happening, some people just can't get it. But if you show them and then they actually do it, they will grasp it. The next one, Genjitsu, is the facts. What has actually happened in a given location? So these are, as you see, these three are very related. The real place where it's happening, go see. So go see the real place and get the facts. So next we have Hansai, self-reflection. So you need to recognizing and taking personal responsibility for a problem. So don't blame somebody else. Just take personal responsibility for it. That doesn't mean you need to say it's all yours and fall on your sword or whatnot. That means take responsibility for it and say, it was my fault. It messed up, but I'm going to take the lead in fixing it. A manager wants to hear that more than, yes, it was my fault that it screwed up, and then nothing else. You don't say anything else. Well, if you identify, yes, I screwed up, but I'm going to take the lead in fixing it, most managers will be like, awesome, go for it. So the next one, Kaikaku, the plan. So a rapid change event to focus on evolution or large improvements. So a large effort with bigger effects over a longer period than a Kaizen event. You're going to hear a lot of things mostly said about Kaizen. Kaizen is just continuous improvement. So you'll probably hear things like Kaizen event. Well, that's where they all come together and they do it's kind of like everybody comes in and they focus hard on one process. And it might only take a week or a day that they actually do it. It's not meant to be a long, drawn-out event. So sometimes it's called a Kaizen burst or just called a Kaizen event. It's a concentrated effort to engage those involved in a process over 1 to a few days to focus on continuous incremental waste elimination, improving the flow and quality of the work. So next we have Kanban. So this is a visual signal or a card. Have you ever been to a grocery store and seen a blinking light above a cash register? Well, that's a Kanban. When a supervisor sees that, they'll walk over to the register and see what's going on. So it's the different signals mean different things. So that your company might have different colored lights or different flashing patterns or even a siren that goes off. A fire alarm is a siren. So that can be considered a Kanban because it's communicating a message. It means that there's a fire. You need to leave the building. So a Kanban can also be a card system, a visual card system. Like, for example, a box of parts gets emptied. They throw the card onto a platform, and somebody comes by and sees that card. Well, now they'll go run and get more parts to fill what's running out. It could be something that simple. So let's go ahead and move on to even more words. So we have muda. It's a wasteful activity. Any activity that uses resources without creating value. And it's a waste. So we have mura, wasteful inconsistency. When processes are not standardized, it creates muri waste due to inconsistent handling and variation of processes. So if I told the class, go make a peanut butter and jelly sandwich, everybody would probably do it differently because it's not standard. That's a simple example of that. So this next one you've probably have seen, a poka yoke. So this is mistake proofing things. So it's a process and systems put in place to prevent mistakes. These are often visual reminders such as colored outlines around walkways and plants for safety reasons. Have you ever seen a movie where they're going through a factory and they're following a line on the floor? Well, this is a poka yoke. You tell somebody, follow the green line. Well, they follow the green line, it might take them into where human resources is. Or you follow the red line, and it will take you to an emergency exit. You can do these kind of things depending on how your company is. Another one would be, for example, a tool chest. If you get the foam inserts that have the tool cutouts out of them, you can take a quick look when you're trying to put a tool back, and you just need to find the shape that matches the tool. Or if you have a pegboard, you might have somebody who drew an outline of the tool, for example, a hammer, and you can hang the hammer up right where it should be because there's an outline that goes around it. These are examples of a poka yoke, mistake proofing. So this next one is tack time. So it's a German term. It's for a conductor's baton. So it's the rate at which units need to be completed to complete customer demand. So think about it. You need to produce 100 an hour to meet demand, right? So what's your tack time? Well, you need to produce 100 in an hour. So what's 60 minutes divided by 100? That answer will tell you your tack time. So that's your available time for production divided by the required units of production. Then you have Yokoten. It's a horizontal deployment. Spreading information and processes that lead to improved performance across the organization. So once you standardize things, because you might have identified something that was in mura, wasteful inconsistency, where the processes were not standard, you want to get that information out to standardize the process. So you might call it Yokoten or horizontal deployment. So let's go ahead and move on to inventory here. There's a lot of problems that are hidden by inventory when we're looking at companies. So if you have a lot of inventory, it's kind of like an iceberg. You see you have inventory, you can see it on spreadsheets, you can actually see it in warehouses, and all that kind of stuff. But when you have an excess amount of something, you might have, some workers might take some home, known as pilferage or shrinkage. You might have some damaged items. Forklift turns a corner too tight, hits some of the product. Now you have some damaged product. Or you might have internal quality problems. If you have 1,000 units and there's a problem with the units, well, you might not notice that problem until the 1,000 are gone, or at least 100 are sold, and now customers are complaining. But you still have 900 units that aren't up to quality standards. What are you going to do with those? Some companies continue to sell them and just will deal with the warranty claims afterwards. That's not a very good idea, but some companies choose that. So the reason for having excess inventory is usually because of forecasting, because of the mismatches between supply and demand, or changing demand patterns. So forecasting is essentially a sophisticated wild guess. I mean, yes, there is some data that goes with it, but if you can figure out and get your data good enough, your inventory that you produce should come close to the demand. It will never, ever, ever match demand. It just will never do it. So don't think that your forecast is ever going to be perfect. Just like the weatherman can never get the forecast correct. Like when they say it's going to rain 50%. Well, if either way it goes, the weatherman can say he was right because, well, I said 50%. That means it could and it might not. So, but then we have our unbalanced lines and our supplier quality problems. So our production lines might not get balanced because our supplier is sending poor quality items, poor quality raw materials. If that happens, we might have enough of everything, but we're missing one part, one raw material item to send through the production line. So the production line is stopped because of that poor quality. That's not a situation you want to be in when you're in supply chain. So you might need to reach out to another one. But, how does this inventory vary by industry? Well, let's take a look at that. So we have our industry sector, let's say fast food. So if you take McDonald's, Burger King, whatnot, they usually have about 8 days of inventory in their location. That might not be for everything that they have on the menu, but they have 8 days. So if they didn't get another delivery for 8 days, they might be able to last that long. So that means they would turn over their inventory 45.8 times. To get that number, you just basically take 365 divided by 8. Retail grocery, 28.2. So that retail grocery, that would be not the meat, not the fresh produce. That would be more of the box stuff that you might find in the center aisles. So that stuff could sit on the shelf for nearly a month. So that would only turn 13 times. Beer as a beverage, 38.2 days of inventory. It's going to turn over 9.6 times. And then you can see the rest of them here. Tobacco products. Tobacco can sit there for an awfully long time, almost 300 days. It only turns over 1.2 times. So if you look at this, if you're in supply chain, the more inventory turns, the more you're going to be working to place orders and make sure it comes in and all that kind of stuff. And the less inventory turns, you're not going to be doing it as much. So it depends on the industry you head to. But let's look at total quality management, because that's another view of how our quality is for lean. It's another building block. So we have our DMAIC that's under Six Sigma here. DMAIC. Define, measure, analyze, improve, and control. So Six Sigma, it was coined or created to refer to the coupling of lean and total quality practices. Now, topic 8 dives a little bit more into Six Sigma. So I just want you to understand the DMAIC, define, measure, analyze, improve, and control. So this is also in other areas such as project management. So keep this in mind, the DMAIC here, DMAIC. So the next building block we have is SMED, SMED. This is the single minute exchange of dies. So if you have a stamping press and you need to change over from one product to another, this is that time that it takes to go from one where you're starting to disassemble the dies of a stamping press to switch it over to the next one. So it's the downtime. So if you can get it down to the single minutes, so that'd be 0 to 9 minutes, that turnover is what's being measured here. So we're trying to reduce it down all the way. Now, sometimes, depending on the machine, it might take a day to convert it to another product line. So we have some manufacturing around in some of the local cities here nearby, and they actually have a system where they also do maintenance when they're switching over dies. And that could be beneficial. So that's what they chose to do. So single minute exchange of dies. SMED, SMED. Keep that in mind. So this is how to minimize the setup time for a new production line. So our next building block is to reduce and balance cycle times. This is where the TAC time comes in, TAKT. So this is your available minutes for production. Remember, minutes for production divided by the required units of production equals your TAC time. So if we had 8 hours times 60 minutes, so we can figure out that number, divide that by 200 units in this example, that means we need to be producing 1 unit every 4.8 minutes. That's a TAC time. So we need to produce at that pace to meet that demand. So if we're producing at 4.9 or 5 minutes per unit, we're going slower and we're not going to meet demand. But if we're producing at 4.8 minutes per unit, we're actually going to be ahead of schedule when it comes to meeting our demand. So, and manufacturing lines actually pay attention to this. That's how they can plan their master production schedule. So let's go ahead and look at 3 more building blocks of lean. Parallel processing. So we set up workstations so that multiple workers can work on the process at the same time. So if you have a bottleneck, you can set up a parallel processing where maybe 2 people are doing that step to reduce the bottleneck. And it's just parallel, because half the work might be going to one worker, the other half might be going to the other worker. That's simple. Multi-function workers. So these are the ones that are cross-trained. So it allows for a worker substitution if workers are ill, on vacation, or a problem in a certain area. So imagine that you're trained on one piece of equipment in a warehouse and your buddy calls out sick. Well, the warehouse manager might say, hey, we need you over there. If you're trained in it, you can go over there. So you're a multifunction worker. This is also known as cross-training. So we also need a organized work environment. There's a place for everything and everything in its place. I'm sure you've heard that quote. So we need to make sure we put things back and it's organized. And then finally, we have what's called our root cause analysis. So the first sign of a problem that we see is usually not, let me say it again, not the cause of the problem itself, but rather a symptom of the problem. Like, for example, you get sick. You have a sore throat, you're coughing, you have a headache. Well, those are symptoms. Those are not the root cause of why you're ill. You might be ill because you have a virus, for example. If that's the case, well, the doctor's going to treat the virus, not the symptoms. Or they'll treat the bacteria, not the symptoms. So hopefully you understand the root cause. But one method to figure that out is asking why, the question why, 5 times. So let's say here, you have a piece of equipment that broke. Well, why did that piece of equipment break? Well, it overheated. Well, why did that piece of equipment overheat? Well, the coolant wasn't working. Well, why did the coolant not work? The pump is broken. Well, why is the pump broken? Because they haven't fixed it yet. Maintenance hasn't fixed it yet. And you can keep going, but we've already crossed 5. Sometimes you'll need more, sometimes you'll need less. But we can say, why did maintenance not fix it yet? Because no one put in the work request yet. Well, there's your root cause. No one put a work request in for a broken coolant pump. So you see how that can work? And no, do not go and ask your parents why. You probably did that as a kid. It's not. Don't ask them why. Don't do that. It's not what I'm telling you to do. But trying to find out the root cause will definitely help you when you get into your careers, regardless of your major, to understand the root cause of a problem. So next, we're going to go into value stream mapping in our next video. But the building blocks are where our lean journey starts. And understanding these tools that we've gone over will definitely help us move forward to better utilize lean in our workplaces.